Hello everyone, my name is Anmol and I am your chemistry SME. Today we are solving FLT2 chemistry section. So let's start. Question number 51. We are given with the carbocations and we have to find the stability of the carbocation. So let's start. First of all, we know the stability of carbocation depends on 3 degree, 2 degree or the degree of the carbocation. 3 degree is more stable than 2 degree followed by 1 degree. Then it is directly proportional to the plus I effect and inversely proportional to the minus I effect. Inversely proportional to minus I effect. If we combine all three conditions, we will get option 2 is our correct answer, which is first of all, this will be the least stable because of 3 minus I effect. This will be more than that 2 minus I effect group, 1 minus I effect group and 0 minus I effect group. Okay, so option number 2 is our correct answer. Now question number 52. We are given with the molecule and we have to match. Okay, so first of all, ethane, which is ethane. From ene you can clearly say it will be a single bond. In single bond we have just one sigma bond and no pi bond. Okay, so answer will be one sigma bond and zero pi bond. Okay, so one sigma bond, so this will be correct. Now for ene we have double bond, means we will have one pi bond and we will have one sigma bond. Okay, for ine we directly say we have one pi bond and two we have one sigma bond, we have two pi bond. Okay, so clearly we get option number 2 as our correct answer. Okay, now question number 53. A compound with a molecular formula C6H14 has two tertiary carbon. Its IUPAC name is. Okay, so for question number 53, if it's asked, it says it's an alkane or it's alkene or it's alkyne, we can directly say by the general formula. We can directly say by the general formula, but it is not asking for the its general formula. It's asking for IUPAC name. Okay, so we have to try to draw the structure, and after drawing first one, two, three, four, five, six. uh, First of all we have to draw all the carbon, then we have to satisfy the condition, means it is asking for two tertiary carbons. Okay, after drawing all these possible structure, you will find that only option 2 can be our answer, which is 2,3 dimethyl butane. Okay, so let me do 1 2 3 4. Now on 2 and 3 it is dimethyl, means 1 2. Now 2 3 dimethyl butane. So okay, option number 2 will be our correct answer. Okay, if it's asked for its general formula, then we can directly say by we have general formula CnH2n plus 2, we have CnH2n. Like this we can comment on the general formula. Now let's come on question number 54. Question number 54 is asking, we have matched the column. Okay, so we have matched the column and we have to match the column A by column 2. Okay, so first of all we have a reagent which is ozone and ZnH2O. Okay, so directly it is an ozone lysis reaction and which is reductive ozone lysis. Okay, so this bond will break from here and two molecules of the same compound from this side, this double bond will break and O bond will, oxygen bond will attach. Okay, now in second reaction we have benzene, then followed by anhydrous AlCl3. So we know anhydrous AlCl3 is an reagent of Friedel-Crafts alkylation reaction. Okay, so Friedel-Crafts alkylation reaction will take place, and we know CrO3 is an oxidizing agent, so it will oxidize OH group to ketone group. Okay, also KMnO4 KOH with heat is also act as an oxidizing agent, and it will oxidize alkane to carboxylic acid group. Okay, so by combining all these, we get our correct answer as option number 4. Now let's come to question number 55. On heating, some substances changes directly from solid to the vapor state without passing through a liquid state. The technique used for the purification of such solid substance based on this principle is known as. Okay, so this is a theoretical question. Okay, so sublimation is the process where a substance transition directly from the solid to the vapor state without passing through the liquid phase. This property is utilized for purifying solid like naphthalene or iodine that can sublimate upon the heating, leaving no volatile impurity behind. Okay, so option number 1 will be our correct answer. Now question number 56. Which of the following reaction will not give primary amine as product? Okay, so here are the four reaction. Okay, so first of all, CS3CN on reaction with BROH. Okay, Br2KOH. Okay, so this will produce CS3 CH2 NH2. Okay, so this will producing 1 degree amine. Okay, in option number 2 we have CH3CN. We are reacting with lithium aluminum hydride. Okay, so it will we know lithium aluminum hydride will act as a strong reducing agent, so 2 degree amine will form here. Okay, now CH3NC isocyanide group is there. In option 2 we have cyanide group, but here we have isocyanide group, and we are reacting with lithium aluminum hydride followed by water. Okay, so the product here will be 1 degree amine. Now CS CS3 CO NH2, we have amide group followed, then we are reacting with lithium aluminum hydride. uh, okay, so it will give 1 degree amine as product. So now let's comes to next question, which is question number 56. So we have list A, no, it is question number 57. So we have list 1 and we have list 2. So we have to match. Okay. So first the options are coke, diamond, fluorines and graphite. Okay. So all item related to carbons are given there. Now we have to match with list 2. Okay. So let's see. First of all, coke. We know coke used as a reducing agent. Coke is a carbon-rich material used in the metallurgical process to reduce metal oxide. Okay. Now we have diamond. Carbon, diamond. Carbon atom are sp3 hybridized. Diamond has a tetrahedral structure with sp3 hybridized carbon atom giving it exceptional hardness. Yes. Okay. Now we have fluorines. Cage-like molecule. Fluorines are spherical or cage shaped structure of carbon such as C60. Cage shaped, or you can say they are arranged in a football like manner. Okay, now in graphite, used as a dye lubricant, graphite layered structure with delocalized electrons allowed it act as a lubricant. Okay, so the correct option will be option number A. No, correct option will be option number 3. Now comes to question number 58. Here following 7 compounds are given, and we are it is asking the number of compound which obeys Huckel rule. Okay, so we know, first of all we have to know what is Huckel rule. Okay, Huckel rule says that a compound which obey 4n plus 2 pi electron rule, then you can say that compound will follow Huckel rule. Okay, so first of all we have to calculate the number of pi electrons the compound are having. Okay, so directly we can say in first compound 1 2 3 4 5 means 5 multiplied by 2, we have 10 electrons which is obeying 4n plus 2 pi electron. Okay, in second we have 6, so it is also obeying. In third we have 4 not obeying, we have 4 not obeying, it has 2 obeying, it has 8 not obeying, 1 2 3 4 5 6 7, 7 multiplied by 2 14, means it is obeying. So option number A, B, 5 and 7, 4 compounds are there, so option number A will be our correct answer. Now question number 59. We have column 1 and we have column 2, we have to match them. Okay, oxide of sulfur, nitrogen dioxide, carbon dioxide, nitrate in drinking water, lead. Okay. So oxide of sulfur can cause respiratory disease. Sulfur oxide uh, irritate the respiratory tract and can cause bronchitis and asthma. Okay. Option number two, nitrogen dioxide, red haze in traffic and congested areas. Okay. Carbon dioxide leads to global warming, is a greenhouse gas that traps heat, leading to global warming. In option number four, we have nitrate in drinking water, blue baby syndrome, high nitrate level cause these diseases that reducing oxygen delivery to tissues. Fifth option is lead, damage to kidney. Lead exposure is toxic, affecting the kidney, nervous system, and other organs. So matching all these, we get option number one is our correct answer. For question number 55, 59, option number 3 will be our correct answer. Now comes to question number 60. Which of the following amine can give the carbonamine test? First of all, we should know, we have to know what is carbonamine test. So carbonamine test is a test for the detection of primary amines, both aliphatic and aromatic. But only primary amines can give the carbonamine test. Okay. So first of all, we can directly see this is a 2-degree amine, not a primary, so it can't give. It is a 3-degree, it can't give. Uh, it is also a secondary 2-degree amine, it can't give, but it is a 1-degree amine, so it can give the carbonamine test. So option number 4 is our correct answer. Now comes to question number 60. 61. When 20 gram of naphtholic acid C11H8O2 is dissolved in 50 gram of benzene, CF value is given, then a freezing point depression of 2 Kelvin is observed. We have to find the Vent Hoff factor. Okay. So first of all, the equation for the freezing point is delta TF is equals to I into KF into molality. Okay. So we have to find all these things step by step. So first of all, we are calculating a molecular weight. So molecular weight will be 172 gram for the given acid. Okay. Molecular weight is 172 gram. Okay. Now we have to calculate the number of moles. We are calculating number of moles and molecular weight for the finding the molality. Okay. For finding molality. Now molality is number of moles divided by mass of solvent in kg. Okay, so the molality comes out to be 2.32 molal. Now we can directly put all this in equation. So we get 2 is equals to I, we have to find out. Kf value is 1.72 and molality value comes out to be 2.32. Okay, so correct answer for I is equals to 0.5. So Vent Hoff factor is 0.5. Now comes to question number 62. The equilibrium constant for the reaction, given reaction at temperature T is itna. We have to find the value of Kc for its reverse reaction. Reverse reaction and some change in the stoichiometric coefficient. Okay, so let's see. So to find out the equilibrium constant Kc for the second reaction. Okay, so this is the original reaction and Kc value is given. Okay, when we reverse the reaction, the Kc value changes to means mu Kc is equals to 1 by Kc 1 by Kc when we reverse the reaction. Okay, now in second reaction we have reduced all the stoichiometric coefficient by 1 by 2 power. When it will be reduced by 1 by 2 by reduced by half the power, we will just reduce it by 1 by 2. Okay, just reduce as 1 by 2, and now we can calculate its value, which is 2.5 into 10 raised to power of 3 put into 10 raised to power of 3 and key power 1 by 2. So it will comes out to be 50. Okay, so correct answer will be option number 2. Now comes to question number 63. In the reaction, PCl5 gives PCl3 plus Cl2. The partial pressure of PCl5, PCl3 and Cl2 are given at equilibrium. If the partial pressure of PCl3 and PeCl3 and Cl2 are increased twice, then what will be the partial pressure of PCl5 uh, is in ATM at new equilibrium condition. Okay, so question number 63. So first of all, it is reaction is given that PCl5 is giving PCl3 plus Cl2 gas. So we can calculate Kc value, which is the concentration of product divided by concentration of reactants. Okay. Now equilibrium constant remain the same. Okay. So we are calculating the Kp values. Partial pressures or partial pressure of product, then followed by pressure divided by partial pressure of reactant. Okay. Now, as concentration are doubled for PCl3 and Cl2. Okay, so we are just doubling the concentration, and by just doubling the concentration, we gets this. Okay, so Kp is equals to 0.1. Kp's value is 0.1, so 0.1 is equals to 0.3 multiplied by 0.4 and divided by PCl5 concentration, which we have to find out. Okay, so by solving all this, we get PCl5 concentration as 2.4, not concentration. We have to find its partial pressure, which comes out to be 2.4. Question number 64. Which of the following solution does not act as buffer? Okay, so when buffer is formed when we add a weak acid with a strong base, or we add strong acid with a weak base, or it can also be formed when we add weak acid with weak base. Okay, so let's start. Option number 1, H3PO4 plus NaH2PO4, HCN, KCN, HCl, NH4Cl, um, formic acid with formic acid salt. Okay, let's see. So, in option number 3, HCl with NH4Cl does not act as buffer because HCl is a strong acid which does not form a buffer with its salt. Buffers require a weak acid and its conjugate base, or a weak base with its conjugate acid. Okay, so we can say option number 3 will be our correct answer. Now question number 65. If the slope of a line of the graph between dissociated concentration of reactant and time minute for a zero order reaction is 0.02, then the initial concentration of the reactant, if after 30 minutes the concentration is 0.05 mole liter inverse, is okay. So we have given that the zero order reaction is this. So the formula for zero order reaction is AT is equals to at time 0 minus KT. Okay, so here AT is given, time is given, and K is given. Okay, so directly putting all the thing in the formula, we get 0.05 is equals to concentration of AO minus 0.02 into 30. Okay, if we solve, we get answer at 0.65. So option number 2 is our correct answer. Now comes to question number 66. The value of KSP for B2CO3 is 3.2 into 10 raised power of minus 5. The concentration of B plus in its saturated solution is, okay. Now the solubility product KSP for B2CO3 is this. It will break in the form of 2B positive plus carbonate ion. Okay, now the KSP value will be this, which is B plus whole square into carbonate concentration. Okay, so let assume the concentration of carbonate be X. So the concentration of B plus ion is 2x. So the KSP will be, if we multiply 2x into 2x square into x, so it comes out to be 4x cube. Now the given KSP is 3.2 into 10 raised power of 5. So after solving, we get the value of x as 4 into 10 raised power of minus 2. 4 into 10 raised power of minus 2 means option number 4 is our correct answer. Now question number 67. Assertion and region problem. Okay. The property of beryllium are similar to that of aluminium. Reason is both the elements belong to the same group. So let's check. The property of beryllium and aluminium are not similar due to their diagonal relationship, not because they are in same group, This similarity arises because both are small, highly charged cations leading to comparable properties such as amphoteric behavior and covalent bonding tendency. So option number 1 means both assertion and reason are true, but the reason is not the correct explanation of the assertion. Okay, now comes to question number 68. Okay, so it's the question from atomic size. We have to tell the order of size. Okay, four options are given: beryllium, lithium, then potassium, then barium. Okay, so first of all, the basic thing for atomic size is that it increases down the group and decreases along the period. When we go along the period from left side to the right side, it decreases; from up to down, it increases. Okay, so let's see. Moving hmm. Moving right in the period, atomic size decreases. Moving down in the group, atomic size increases. K and B are in the different group and period. With Ba being larger, B is the smallest among the element. Okay, so by this we can conclude that B is the smallest, then lithium, then potassium, then barium. So option number 1 will be our correct answer. Now comes to question number 69. Which of the following is not related with the lengthenite contraction? Okay, so atomic radius of Zr and Hf is almost same. Ionization energy of Hg is more than that of cadmium. Atomic radius of aluminium and gallium is almost same. Atomic radius difference between indium and thallium is less than that of gallium and indium. Okay, let's check. For question number 69, lengthenoid contraction does not affect the atomic radius of aluminium and gallium. The similarity in their radius is arises deep from the d electron poor shielding in gallium independent of lanthanoids. Okay, so option number 3 is our correct answer, and all option number 1, 2 and 4, these are related to the lanthanoid contraction. Okay, question number 70. Among the following oxoacid, the correct decreasing order of acidic strength is. Okay, so we are given with HClO4, HClO3, HClO2 and HOCl. Okay, so let's check. So we know when the oxidation state of an acid increases, then its acidic property increases. Its acidic property increases. Why? Because we know acid are donor. Acid formed by donor and base are lone pair acceptor, and acid are lone pair donor. Okay, so means the compound which is in its more oxidation state, then the compound is found to be more acidic. Okay, so clearly option number 1, here Cl is in +7 oxidation state, here in +5, here in +4, sorry, here is in +6 oxidation state, here in +4, and here in +1 oxidation state, plus 1 oxidation state, +1, +4, +6 and +7. Okay, the acidic strength depends on the oxidation state and stability of the conjugate base. The oxidation state of Cl are +7, +5, +3 and +1. Oh, it's +3, and here it will be of +5 because of this hydrogen, 6 because of oxygen, and +1, so +5 because of hydrogen. Okay, so correct answer is option number 1. Now let's come to question number 71. Which is the most easily liquefiable inert gas? Okay, xenon is the most easily liquefiable because it has the largest size and the largest polarizability among noble gases, making van der Waals forces stronger. Okay, so xenon is our correct answer. Now comes to question number 72. Fluorine has the highest electronegativity in its group on the Pauling scale, but electron affinity of fluorine is less than that of chlorine because, okay, first, the atomic number of fluorine is less than that of chlorine. Fluorine being the first member of the family behaves in an unusual manner. Chlorine can accommodate an electron better than that of better than fluorine by utilizing its vacant 3d orbital. For option, small size it is talking about. Okay, so let's check. So fluorine has the higher electronegativity, but highest electronegativity, but it has less electron affinity than chlorine because a valence electron in multi-electron atom is attracted by the nucleus and repelled by the electron of inner shells. The combined effect of this attraction and repulsive force act on the valence electron experience less attraction force from the nucleus. This is called shielding or screening effect. So option number 3 is our correct answer. Now question number 73. A 200 ml solution contain 0.15 moles of sodium hydroxide and 0.075 moles of HCl. What is the initial pH of the solution? Okay. So first of all, we have to write the equation. So the equation will be NaOH plus HCl will gives out NaCl plus H2O. Okay. So since NaOH is a strong base and HCl is a strong acid, they will react completely to form salt and water. Okay, so the initial concentration of NaOH is this, and for HCl is this, which is 0.6 and 0.3. Okay, so after reaction we can conclude that HCl is completely reacted and NaOH is not completely reacted, means HCl will behave as limiting reagent. Okay, since NaOH is in excess, the solution will be basic. Okay, to find the pH we will use pOH formula. pOH is equals to minus log of concentration of OH. Okay, so which it comes out to be, pOH comes out to be 0.52, but we have to calculate the pH. We know, we also know pH plus pOH is equals to 14, so the pH will be 13.48. So option number 4 will be our correct answer. Now question number 74. Same quantity of current is passed through molten NaCl and molten Al2O3. If 4.6 gram of Na was deposited is deposit in one cell, the mass of aluminium deposit in the other cell is. Okay, to solve this problem we can use the concept of electrochemical equivalence. The mass of Na is 4.6 gram, and its molecular weight we know comes to be 23 gram. So let's check now. So we can calculate the number of moles. So the number of moles comes out to be 0.2 mole. Now same quantity of current is passed in both cell. Okay, now so we know the molar mass of aluminium is 27 gram. So mass of aluminium deposit is equals to number of moles of aluminium multiplied by molar mass of aluminium. Okay, so moles of aluminium deposit to be 0.2 mole and its molar mass is 27. So 0.2 into 27 will be 5.4 gram. Since the same quantity of current is passed through both cells, the mass of aluminium deposit will be 1 by third of the calculated value. So 5.4 divided by 3 comes out to be 1.8. So 1.8 being option number 2 will be our correct answer. Now question number 75. Total charge required for the oxidation of 2 moles of MnO2 with MnO4 2 minus is. So we have to convert Mn3O4 to MnO4 2 minus. Okay, so 1 mole of Mn3O4 loses 6 minus 8 by 3 into 3 means we have to calculate this value, which comes out to be 10 moles of electron. Okay, so total charge required for 2 moles of Mn3O4 is 2 into 10, which comes out to be 20 farad. Okay, 20 farad means option number 3 will be our correct answer. Now question number 76. The volume of gas at NTP produced by 100 gram of CaC2 with water is, okay. So the reaction is given, which is carbide CaC2 plus 2H2O will give CaOH whole twice plus C2H2. Okay. So we have to calculate the volume at NTP. So let's calculate the number of moles of CaC2. So first of all, we have to calculate the number of moles of CaC2. So the molar mass of CaC2 comes out to be 64 gram. The number of moles of CaC2 will be 100 gram divided by its molar mass comes out to be 1.56 mole. Now from the balanced chemical reaction we can see that 1 mole of CaC2 produce 1 mole of C2H2 gas. Okay, so the total number of moles produced will be 1.56 mole. Okay, now volume of CH2 gas is equals to number of moles of C2H2 gas into 22.4, which is 1.56 into 22.4 comes out to be 35 liter approximately. Means option number 2 will be our correct answer. Question number 77. A green bulb and a red bulb are emitting the radiation with equal power. The correct relationship between number of photon emitted by bulb per second is, okay. So number of photons emitted is equals to number of photons is equals to power divided by energy per photon. So green light has higher energy. We know in green light has higher energy per photon than red light. So Ng will be less than Nr. So Ng will be less than Nr means option number 2 will be our correct answer. Now comes to question number 78. In an excited state, a calcium atom has the electronic configuration this. What is the orbital angular momentum for d electrons? Okay. So we know the formula for orbital angular momentum is capital L is equals to under root L into L plus 1 into cut h. Okay, so now let's solve. We know the value of L, which is azimuthal quantum number for d orbital is L equals to 2. Now putting the value L equals to 2 in the capital L, we get, so we get the value as, okay, we get the value as under root 6 cut h. Okay, so the correct option will be option number 3 will be our correct answer. Now question number 79. Which of the following exhibit only plus 3 oxidation state? Okay, we know this question is from D and F block element. The actinium exhibit only plus 3 oxidation state, whereas Pa, uranium and thorium show multiple oxidation state. Okay, so the oxidation state shown by actinium is only plus 3. Okay, so now let's come to question number 80. The rate of a reaction A doubles on increasing temperature from 300 to 310 Kelvin. By how much the temperature of reaction B should be increased from 300 Kelvin so that rate doubles if activation energy of reaction B is twice that of reaction A. Okay. First of all, we can directly see that this question is from Arrhenius equation. Okay, so Arrhenius equation, we can write the Arrhenius equation as rate doubling relation, which is ln2 is equals to EA divided by R 1 upon temperature T1 minus 1 upon temperature T2. Okay, now the putting all the values of log K2 by K1 is equals to E 2.303 R and solving this inequality, solving this equation in T2 minus T1 divided by T1 T2. Okay, now we are given that K2 by K1 is equals to 2 times of T1. Okay, now putting the value of T by T1 and then now solving, we get log 2 is equals to E divided by 2.303 R and this equation. Okay, now similarly we will calculate this for equation number 2. For equation number 2 we get we put all the equation. Now this will be our equation number 2. After putting all the values, we get equation number 1, equation number 2. And now from simple elimination method, we have to solve equation 1 and equation 2. By direct solving, we get our temperature T2 here, which is 304.92 Kelvin. From this we know T1 is equals to 300 Kelvin and T2 is equals to this. So temperature difference means T2 minus T1, which is 304.92 minus 300, which is 4.92 Kelvin. 4.92 Kelvin is our correct answer. Means option number 3 is our correct answer. Now comes to question number 81. Which reagent will best distinguish between phenol and ethanol? Okay, and the given option are FeCl3, Br2 in CCl4, NaOH or HCl. Okay. Phenol, phenol reacts with FeCl3 solution to form violet complex. Distinguish it from ethanol, which does not react. Okay, so the correct answer is FeCl3, because phenol on reacting with FeCl3 it form violet color complex, but ethanol does not react with FeCl3. So the correct answer is option number 1. Uh, 82 question is very easy. Sucrose. Now question number 82. Sucrose on hydrolysis gives. Okay. Hydrolysis of sucrose yields alpha D glucose and beta D fructose due to the cleavage of the glycosidic bond. Okay, so the correct answer is option number 2. Now question number 83. How many liter of oxygen at 1 atm and 273 Kelvin will be required to burn completely 2.2 gram of propane, which is C3H8? Okay. Now question number 83. So the first of all we have to write the balanced chemical equation for this combustion. Okay. So the balanced chemical equation for this combustion will be C3H8 plus O2 will gives out CO2 plus H2O. Okay, now we will calculate moles of C3H8, which is 2.2 divided by 44, comes out to be 0.05. Now oxygen required will be 0.05 into 5, which is 0.25 mole. Now at NTP we note that 1 mole of any gas will contain 22.4 liter. So 0.25 into 22.4 will give out 5.6 liter. Means option number 3 is our correct answer. Now question number 84. If a pure compound is composed of X2Y3 molecules and consists of 60% X by weight, what is the atomic weight of Y in terms of the atomic weight X? Okay. So first of all, the molecular given molecular formula is X2Y3. Okay. Now let's the atomic weight of X be mx and the atomic weight of Y be my. Okay. So the total molecular weight will be 2mx plus 3my. Okay. Now we are given that X makes 60% of the compound. Okay. So we can write 2mx divided by 2mx plus m3 will into 100 will be 60%. Okay. So it comes to be 60. Now we are just required to solve the given equation, which is 2mx is equals to 0.6, 2mx plus 3my. Okay. Now after solving we get my is equals to 0.8 divided by 1.8 mx. So a relationship between mx and my is equals to 4 by 9 mx. 4 by 9 mx means option number 2 is our correct answer. Now question number 85. The ratio of wavelength of a proton and alpha particle will be 1:2 if there. Okay. So we know that the ratio of wavelength of proton and alpha particle means lambda of p divided by lambda of a is equals to 1 by 2. Okay. Lambda of alpha. Okay. So we can write in just a second, m alpha m alpha into v alpha divided by mp into vp. Okay. Now putting the value, we get 1 by 2 is equals to 4 into m alpha divided by volume of proton. Okay. Now solving this we get vp divided by v alpha is equals to 8. Okay. Now we can write the equation for kinetic energy. Kinetic energy is equals to mp into, because half will be cancelled out, so mp into vp square divided by m alpha into v alpha square. So it comes out to be 16 ratio 1. 16 ratio 1. Okay, means option number D is correct. Option number D is correct. And okay, yes, so correct answer will be option number C, which is B and D. Now comes to question number 86. Question number 86. So we have matched the following list A and list B. So we have to do the match the following. Okay. So first is benzene on reaction with CO, HCl and anhydrous AlCl3 CuCl. So this is known as Gatterman-Koch reaction. So all are very important name reaction. Okay. So this is Gatterman-Koch reaction. Now RCONH3 with NaOX. Okay. So this is a very famous reaction which is haloform reaction. Okay, now RCH2OS plus uh, RCOOH with concentrated H2SO4. This is esterification reaction which is used to make perfumes and other esters. Okay, now at last we have RCH2COH in presence of red phosphorus. If any equation and the reactant is red phosphorus, then this is only possible in Hell HVZ reaction. Hell Vonard Zaleski reaction, HVZ reaction. Okay. Now comes to question number 87. What is the IUPAC name of the organic compound formed in the chemical reaction? Okay. We have acetone and we are reacting with C2H5 MgBr, dry ether, and we have H plus. Okay. So on reacting CS3CO CS3 with this reagent, it gives CS3C C2H5 CS3 and OH. So the IUPAC name we have 1 2 3 4. 4 carbon means bute will come. We have OH group on second position and methyl group on second position. So this is our correct IUPAC name. Okay. So correct answer is option number 4. Yes. Now comes to question number 88. The compound which give a positive iodoform test is the compound which give positive iodoform test. Okay, iodoform test is given by compound with CS3CO or CHOH CS3 groups. Okay, so acetaldehyde has CS3CO, so it gives a positive iodoform test. Benzaldehyde, methanol, and propanol lacks these group. Okay. Now question number 89. Which of the following compound will undergo nucleophilic substitution most easily? Okay. So benzyl chloride undergo nucleophilic substitution easily because the benzyl group stabilize the intermediate carbocation. Chlorobenzene and vinyl chloride resist substitution due to resonance and partial double bond character. So tertiary butyl chloride favors SN1 mechanism over benzyl chloride. So option number 2 is our correct answer. Now question number 90. Among the following complex, the one which shows 0 CFSC value. Okay. So to determine the complex has 0 CFSC value, we need to determine electronic configuration of each of the metal ion. Okay. So first of all, we will calculate its oxidation state. So Mn, it has clearly +3 oxidation state. So configuration will be 3d4. So octahedral field. So it occupy both T2G and EG, resulting in non-zero. Okay, so option number 1 can't be possible. It has also D5 electron. It has D5 configuration with a high spin, means 5d electron occupy both T2G and EG equally. This result in 0 CFSC value. So option number 2 is our correct answer. Similarly, we can find the oxidation state, then we will find electronic configuration and answer the question very easily. Now comes to question number 91. Which of the following is a paramagnetic complex? Okay, so MoCO whole 6. So here oxidation state is 0. So Mn in this complex is in +6 oxidation state, D0 configuration, and CO is a strong field. So the complex is diamagnetic. Okay, so this complex is diamagnetic, not paramagnetic. Okay. Similarly, if you check option number 2, it has oxidation state of +3, so D6 configuration. So it means it has also diamagnetic configuration, not paramagnetic. Now in option number 3, it has D8 configuration and it has strong field ligand. This complex is also diamagnetic. But if you check option number 4, this is a weak field ligand with D7 configuration. So it will definitely a paramagnetic complex, means it will definitely have a unpaired electron. So option number 4 is our correct answer. Now question number 92. The number of unpaired electron in the complex is, okay. First of all, we will write set electronic configuration. After writing electronic configuration, we will check um, electronic configuration is D3. By first we will calculate oxidation state. Then from this we can say that its electronic configuration will be D3. Then according to the Hertz rule, the electron will occupy orbital singly before pairing up. So all three electrons are unpaired. So option number 4 is our correct answer. Now question number 93. The rate of reaction between two reactant A and B decrease by a factor of 4. If the concentration of reactant B is double, the order of reaction with respect to reactant B is, okay. When the concentration of reactant B is double, the rate decrease by a factor of 4. Yes. This indicate an reverse relationship between the concentration of B. So mathematically we can represent it by rate. Rate is inversely proportional to 1 upon B square. So rate is equals to K divided by B square. So K is a rate constant. So order will be -2. So correct answer will be option number 2. Now comes to question number 94. The work done during the expansion of a gas from a volume of 4 dm cube to 6 decameter cube against a constant pressure of 3 atm. Okay. We have to find the work done. So we know work done is equals to minus of P delta V. So it will comes out to be -3 into 6 minus 4 into 2 means -6 atm. Okay. Now we'll convert atm to joule. Okay. Means -6 into 1.1 into 32, which approximately comes out to be 608 joule. Means option number 2 is our correct answer. Now comes to question number 95. Considering entropy as a thermodynamic parameter, the criteria for the spontaneity of any process is, okay. So delta S total, we know that totally delta S can be represented as delta S of system plus delta S of surrounding, which is greater than 0. So the second law of thermodynamics states that for a spontaneous process, the total energy change, which is system plus surrounding, must be greater than 0. Okay. So option number 1 is our correct answer. Now comes to question number 96. The solubility of a common salt is 36 gram in 100 gram of water at 20 degrees Celsius. If the system 1, 2, 3 contain 20, 18 and 15 gram of salt added to 50 gram of water in each case, the vapor pressure should be in order. Okay. So the solubility of common salt in water at 20 degree is 36 gram divided by 100 gram of water. This means 50 gram of water. The maximum amount of salt that can dissolve is 18 gram. Okay. Now analyze three system. First is 20 gram salt plus 50 gram. Since the limit is 18 gram, the excess 2 gram of salt not dissolved. The vapor pressure depends on the dissolved salt, which is 18 gram. Okay. Similarly system 2, 18 gram of salt dissolving, the vapor pressure will be same as system 1. Okay. Now similarly in system 3, okay. Similarly in system 3, so vapor pressure order, since system 1, 2, oh, okay, let's check system 3 as well. This system is below the solubility limit with only 15 gram salt dissolving. Since the concentration of dissolved salt is lower, the vapor pressure will be higher. Okay. So vapor pressure order is, since system 1 and 2 have the same amount of dissolved salt, their vapor pressure will be equal. System 3 has a lower concentration of dissolved salt, resulting in a higher vapor pressure. Okay. So correct answer will be option number 4. Now comes to question number 97. Question number 97. The low density of ice compared to water is due to. Okay. So we can directly say it is due to the hydrogen bonding interaction. So option number 1 is our correct answer. Question number 98. Which of the following pairs is isostructure? Means having the same shape and hybridization. Okay. So BCl3 and BrCl3 both molecules are trigonal planar with sp2 hybridization for both. So they are isostructure. Okay. Now NH3 and NO3 minus, it is a trigonal pyramidal and it is trigonal planar. So not isostructural. This is isostructural. So our correct answer will be option number A. But let's check option number 3 as well. NF3 is trigonal pyramidal and BF3 is trigonal planar. We can directly calculate by calculating its hybridization. Okay. Similarly, in option 4, both are tetrahedral and have sp3 hybridization. So it is also isostructural. Okay. So option number 4 is our correct answer, not option number 1. Option number 4 is our correct answer. Now question number 93. Among the following mixture, dipole-dipole as the major interaction is present in. Okay. So dipole-dipole interaction, acetonitrile and acetone polar interact via dipole-dipole force. Okay. So clearly option number 4 is our correct answer. So the reduction potential values are given for aluminium 3 plus 2 aluminium and Mg 2 plus 2 Mg. Similarly for copper, which one is the best reducing agent? Okay, so the best reducing agent is Mg, has the lowest reduction potential, which is lowest in the minus, making it the strongest reduction potential. If the value is more negative, then it will be the strongest. More negative value is the strongest, and the less negative value is the is you can say most oxidizing, most oxidizing. So option number 2 is our correct answer. So thank you everyone.